Welcome to the session on projectiles, horizontal projection. The objectives for this session are to model motion under gravity for an object projected horizontally. We can model the motion of a projectile as a particle being acted on by a single force, gravity. In this model, we ignore the effects of any rotational movement on the particle and air resistance. Consider this diagram, where a particle is being projected horizontally. We analyze the particle's motion by considering vertical and horizontal motion separately. Notice that gravity acts vertically, therefore there is no force acting on the particle horizontally. When we consider horizontal motion, we're going to in particular use this equation of motion which has been highlighted for our calculations. And this is because a, the acceleration horizontally, equals 0. So when we consider this equation, since we have a equals 0, we can remove this term. Therefore, velocity is constant and s equals vt. Now for the vertical motion of a projectile, acceleration is constant due to gravity. Therefore, a equals g. And we're going to use g equals 9.8 meters per second squared in our calculations unless otherwise stated. Let's now take a look at an example. A particle is projected horizontally at 15 meters per second from a point 122.5 meters above horizontal ground. Find firstly the time taken for the particle to land on the ground, and secondly the horizontal distance travelled in that time. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve this. First, we're going to begin by drawing a diagram. Here's the particle being projected horizontally at 15 meters per second. Here's the distance denoted, 122.5 meters above horizontal ground. And for part A, we are required to find the time taken for the particle to land on the ground. So let's solve this. We're going to resolve vertically first. Notice that the arrow is pointing downwards. So we're going to take the positive direction to be down. And we're doing that in particular because the only force that is acting is gravity. The initial velocity vertically, uy, u subscript y equals 0. The distance above the ground is 122.5 meters. And acceleration equals g. So we're going to apply this equation of motion, s equals ut plus a half at squared, and plug in all the values. This will allow us to calculate the time taken. So plugging in the distance, 122.5, plugging in the initial velocity, ut, so of course 0 times t, plus a half times 9.8, which is g, and t squared stays as it is. Tidying up, we obtain that t equals 5 seconds. We're going to use t equals 5 for part B, when we find the horizontal distance travelled in this time. So let's solve this. Horizontally, taking the direction pointing to the right as positive, we have that t equals 5 from part A, and we have the initial velocity horizontally, ux equals 15, and we have the horizontal distance, s subscript x equals x. So we use s equals vt, since of course the acceleration equals 0 in the horizontal direction, and we have s substituted by x, the distance, the velocity, which is 15, and time, which is equal to 5. And tidying up gives us that x equals 75 meters. Now let's take a look at another example. A particle is projected horizontally at u meters per second from a point 176.4 meters above a horizontal plane. The particle hits the plane at a point which is at a horizontal distance of 84 meters from the point of projection. Find the value of u. Pause the video and have a go. Press play when you're ready to view the solution. So here's our diagram. Here we have u, the velocity of the particle as it's projected horizontally. Here we have the distance above the horizontal plane, 176.4 meters, and the horizontal distance here of 84 meters from the point of projection when it lands. So let's solve this. Again, we're going to look vertically first, and taking the downward direction as positive, we have the initial velocity equals 0, since the particle is projected horizontally, so there's no velocity downwards or upwards. Sy, or S subscript y, equals 176.4, and A equals 9.8, the force of gravity, or acceleration due to gravity. We're going to use this equation, S equals ut plus a half at squared, and plugging in the distance here, 176.4, and the initial velocity equals 0. Multiply that by t, of course, we have 0, and then a half stays as it is. A equals 9.8, and t squared. And now we can solve for t, and this gives us t equals 6. So we have t equals 6 from the previous slide, and we're going to use that for the rest of our calculations. So horizontally, we have v subscript x equals u, the initial velocity. The horizontal distance equals 84 meters. And so we can use the formula or the equation S equals Vt. Plugging everything in, 84 goes here. Initial velocity is u, and time equals 6. Now rearranging gives us that u, the initial velocity, equals 14 meters per second. Now for another example. A particle is projected horizontally with velocity 25 meters per second. We are required to find the horizontal and vertical components of the displacement of the particle and the distance of the particle from the point of projection after 2 seconds. Pause the video and have a go. Press play when you're ready to view the solutions. So let's take a look at this. Here's our diagram. Notice that the particle is projected, of course, horizontally. The initial velocity is 25 meters per second. As you can see from the diagram, we've got that there. And the horizontal and vertical components of the displacement are x meters and y meters, as shown here. And time that we're going to consider is 2 seconds. So let's solve this. Again, we're going to look vertically first. So taking the downward direction as positive, we have the initial velocity equals 0, since the particle is projected horizontally. Sy equals y, the distance, vertically. The acceleration due to gravity equals 9.8, and time equals 2. So we're going to use this equation of motion again, s equals ut plus a half at squared, and plug in all the values. We have ut, because u equals 0, being substituted by 0. The vertical distance is represented by y. We leave half as it is, 9.8 being the acceleration due to gravity, and time is 2, so we have 2 squared here. And so the distance, y, equals 19.6 meters. Horizontally, we have the velocity equals 25, distance is x meters, and time is 2. Using s equals vt and plugging in the values, we have x equals 25, which takes the place of v, times 2, where of course time equals 2. And therefore x equals 50 meters. We're now going to take a look at part B and use the values we've obtained from part A for our calculations. In part B, we are required to find the distance of the particle from the point of projection after 2 seconds. So let's solve this. Let's take a look at this right-angled triangle. We are required to find the distance of the particle from the point of projection. So in the diagram, this value is represented by d, or d meters. Here we have x equals 50 meters and y equals 19.6 meters. Therefore, we can simply apply Pythagoras to find d. And plugging in all the values as shown, gives us that d equals 53.7 meters. This brings us to the end of this session. If you have understood its contents, you should be able to model motion under gravity for an object projected horizontally. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.